Spencer Davies, and I'm here for the boat show, which I think I'm in the wrong place. Because keep talking about programming stuff. But,
And you brought a laptop, which is strange because normally I don't bring a custom System 76 laptop to boat shows.
Well, he was thinking we're talking about corrosion.
oh, yeah.
Probably why you don't have a good time, AJ.
I didn't hear that.
He said it's probably why you don't have a good time, AJ, because I'm not bringing my laptop to the boat show. That's why I'm not.
Well, anyways, yeah, so I'd love to get into Rust. I went on Code Wars and looked at just a simple parens counter, and I'm just like solving that right now, and so it's fun, but I guess people that are much smarter than me are saying it's like amazing, and so I want to find out why that is. I want to be able to argue like AJ and be like, this is why I like it better. So.
But do you really want to argue like me? People don't like it very much.
Don't run. Save yourself.
Yeah, anyways.
All right.
You want to argue like him or with him?
Yeah.
Arguing with me is much more fun than arguing like me. At least for me.
Jordan, I'm a full stack developer. I've been learning Rust or attempting to. I also used Nathan Stock's course, and that helped me a lot. I'm Jojo Bite in the channel, and I've just been going through Rust, trying to build some microservices and various apps and stuff. So.
Cool. Well, that's everybody. So
Glad to see you
online.
made it to the room.
Yeah, thanks for the help.
And online, you've got,
Yeah, we should go around the.
yeah.
Oh yeah, sorry. I forget about online people. You are real people.
We're
and you
staring
matter.
at you, but
You can't prove they're real. They could be bots.
Levi's the guy who, I've never been able to ask Levi a Rust question that he couldn't answer.
Is this one?
It is a failing.
Yeah, I've been doing Rust professionally for a few years now, and I was interested in doing it a little bit before that, been following it for a while. Before that I did mostly embedded C programming, but aside from being a programmer, as you can see from behind me, I'm a collector of obsolete junk. But yeah, that's about it.
Is that a Mac 2 in the background?
No, there's a CRT monitor right there that's hooked up to a Pentium laptop.
Okay.
And then back there, that's a logic analyzer.
Of course.
I do have a Mac Plus that's under a desk over there.
And who are our other friends? Who's TH?
Todd, was that the voice I heard heckling me earlier?
Of course it was. Of course it was.
That's
WM?
well. Wait. Todd needs to give his introduction.
Go ahead.
I'm Todd Hazeman, Todd Punk on the channel. I drink and I know things.
Wow. I think you've said that before.
I have a cup that I was given by one of my employees with that on it.
we have a lot in common. I do that too.
I should have done this for Levi
Yeah, he
too.
knows
So that
things.
way we can have
What?
streamception.
He knows things?
Yeah, he does.
Actually, this is
Oh,
totally
that's-
stupid. Hold on just 1 second. Oh gosh, I'm gonna get better at this. I promise.
Oh, we have another smiling face.
Hold on. Where'd the little button go that I need?
Oh no,
Mm-hmm.
infinite.
Yeah. So here we go. Now the audio and the video are gonna be out of sync, but now I can go through and
We just left our pictures.
there we go.
We're not seeing what you're seeing.
What now? Oh man. I could mirror maybe. I don't know.
This was
No,
disguised
just-
as a Rust meetup, but really, it was
This was
it was
an
AZ.
IT
Let's figure out how to use it.
It's an IT meeting, yeah.
Yeah.
Okay,
The IT meeting.
let's hear from
At the
MW
Disneyland.
next. I think he was the one
Ready
who,
for next time.
or whoever just came on with their video.
WM is Will Murfallon, and his microphone is not working. The guy who came on with his video is Michael Harding, and I will let him talk for himself.
Oh yeah, I'm Mike Harding, or Michael Harding, either way. I am Redoxion on the Discord, and I just like doing Rust as a hobby right now, trying to convince people at work to use it, rewrite our web app in Rust, but we'll see what happens. So far, no luck, but yeah.
You want to do it WASM style? Is that the deal?
WASM, Rust in the back end, however, as long as Rust is in there, you know.
It's not a very defensible position.
I've had to scale back from, hey, we should try Rust to please give it a chance, maybe tighten it a little bit, just put something in there. Got a little bit of pushback, basically.
Okay. Anyone else?
We're gonna have Will, or we're gonna have Jacobobo. Jacobobo. Wait, I'm gonna say it right. Jacobobo.
What's up? I've been doing things in the background, I'm sorry.
Well, you're on.
Well, I'm a dude who does things. I haven't really done any Rust, but I enjoyed what I have done. So I'm here to hang out.
You've done a little bit.
It's true. I did 18 days of advent of code, but that's it.
It's more than half of us.
And I don't know. I wrote things. I have no clue what I'm doing.
Well,
That's the important bit.
I think that marks you as a software engineer. If you come to that realization, you're in the upper echelons.
Sweet.
I have no idea what I'm doing. That's what I think every day.
The criteria for software engineering is not to know what you're doing, is to give others the impression that you know what you're doing. There we go.
Well, then I'd like to let you all know that I'm very good at Rust. And
I'm good at hacker typer.
Well, what I love is those memes that are circulating where they say junior developer and they have some blurb, and then they have mid-level developer, and then they have some blurb that's about greatness and delusions of grandeur, and then they have senior developer and it's the same blurb as the junior developer. Have you seen these memes?
Yes.
They're spot on. Like, junior developer, I'm so stupid, I have no idea what I'm doing, I'm just going to code this as simple as possible. Mid-level developer, master of the universe, I make all the code rain. Senior developer, I'm an idiot, I have no idea what I'm doing, I'm going to make this as simple as possible.
Get that guy a security job.
Yeah.
Okay. Anyone else? So I believe that we were doing lightning talks. So have we got a list of lightning talks, or this is spontaneous?
So lightning talks are spontaneous because I asked several times on the channel, hey, anybody want to go talk? And I got no answers except for I'm busy, and nobody was even good enough to leave me a cricket emoji. That would be great next time. But I want to keep the momentum going, and
So I'm willing to talk about my traits versus closures. I don't have any slides.
well, let me another second here so I can now swappy do this. All right, there we go. Now
Okay.
we're back to you, and let's get the microphone a little bit closer to you if we can. We may not be able to because
So-
technology is hard.
I recently changed my Rust code into something that, I don't know what the next person's going to make of it, but it's
junior level.
This is the
developer,
microphone?
What?
Okay, the microphone here.
Okay,
But-
so.
although
can
it's
everybody hear
pointing
again?
like that, so.
Yeah, okay.
Okay, so
Everybody should be able to hear.
we learned that, okay, if you're trying to put something together by inheriting from concrete classes, you get yourself in trouble. So, okay, have an interface, but try to, inside your thing, your class, whatever language you're using, put together stuff to do the work. Okay. Well, the code that I'm in, the context I'm working in is that most of my life when I've written code has been algorithms. And so I've got this video coming into me at 150 frames per second that I've got to do a whole bunch of stuff. And my boss, our CEO, has a wonderful idea he wants to try it out about every 3 months to try some different algorithm to do different things. So at the top level, I still have video coming in and I have this data structure coming out. That doesn't change very often. But the algorithms I use underneath can change dramatically to what I'm trying to do. And of course, these different algorithms have different parameters and things that they need. Some of these algorithms are stateless, many of them are stateful. So I used to try to define traits and having things implemented those traits to combine and can put these things together until I realized that, you know, I'm not getting any value out of these function names because I constantly have to redesign my pipeline. You know, I don't know if you've worked with like OpenGL or other video processing pipelines I did. You can sometimes have a very deep processing pipeline to things. And because I had to do things that had state to them, what's the way in Rust that I can have a function where I can quickly grab state? I mean, if I was doing F# or some other functional language, I could use currying. I don't know if people here are familiar with currying, but if I have a multi-parameter function and I just put one variable in there at the start, functional languages like Haskell or F# will give you back a function where that's sort of hidden on the inside and you can refer that to your code. So you can return that function to someone else to use, but you've hidden away the first parameter that you did. Well, in Rust, the closest I get to that is a closure. Okay, I define a closure to capture variables. But with a closure, I can just have parentheses that just take data that comes in and gives you, I'll call that a shape of data coming in, and gives you a shape of data coming out. You don't have to define a function name working with closures. You can just call the parentheses the data going in. And I found that's been rather helpful for composition, where I just simply say, okay, what's the processing pipeline that I need to do? And I may want to choose different algorithms I need for the different steps and so forth, but all I really care about is how does the shape of my data? Is it starting as a 2D array and going to 1D array to a structure or whatever that is? And I am combining closures together, and those themselves can be input into closures to do all my stuff. So when I'm calling my routine, yes, I have an interface that you're calling a function, do my thing, whatever I have that. But everything that runs underneath that is all closures now. I have no function names. So there are comments in my code that explain what these things are and so forth. And there are function names for the things that I use underneath. But as far as where I put all the glue together, it's just all closures and no function names. And I also avoid the thing I sometimes see in Rust places where you go function dot function dot function dot function dot function dot function dot function. It's like I don't care about all that stuff. It's all hidden. You know, so I don't know if I'm doing it right, but that, and maybe you're the need for someone else, but I'll open up to say that have people here been using closures very much in Rust? And when you think about interfaces, do you really get a lot of value out of the function, having a function name? Or is it just all about here's my data shape coming in versus my data shape going out? I think in data science, that's mostly what you're thinking about. Levi, what do you think?
So I've definitely got a lot of use out of closures. I don't know if it's exactly in the same way that you're describing, but I find that they're a very useful way to provide kind of contextual access to mutable state.
Yep.
Rather than trying to, return something that somebody else can then modify, you take
So in other languages, I may have used an object, and object-oriented programming, you're hiding this private mutable state on the inside. But that's what I'm using closures for. I don't need to give the thing a name. I don't have to talk about what's in the inside. Just saying, hey, you're giving me something, and I'm returning something to you. And the fact that I'm maintaining all these statistics on the inside in the meantime that I need for my data science. So in my data, I have to keep track of how things change over time. So I have to have mutable state to do that. But another great thing for Rust, I'm able to do mutable state with multi-threading, and I don't have any memory leaks. I don't have any threading problems. I got awfully good about understanding what send means, and some other things to make these things to these FN mute type functions, which are the hardest ones, are the ones to do, not FN once or FN, but FN mute. But it just works great. So has anyone else here ever used closures in Rust or any other language? There's other languages that do closures.
Yeah, I've had difficulties with closures in async Rust, where the move keyword and async can you can start to get in weird situations where you can have move for the closure arguments, right? So that the arguments are actually moved into the future that's generated, and then you can also have that it's an async move and then the open block. So you have two moves as part of this description that you're
moving the data in versus moving the whole. Okay.
Well, because you have the move for capturing the variables that are assigned in the body of your future that's being generated, and then you have the move for the actual arguments, so that they're moved into the future that's generated as well. So you have a move closure arguments async move closure body. So there's some like ergonomic issues with closures that I've had before that feel weird and can be kind of very compiler fighty about there.
So for those who don't use closures, how much value, if it's not a public function, if it's a private or protected member function, do you get a lot of value out of the actual name you give that function?
Are you having a problem where it's not, I'm trying to think of a word, it's where it's I just forgot what I was going to say.
The main design problem to solve for me was I have mutable state I need to control, and I need to compose things. And I found out that trying to find a whole bunch of traits with names and so forth was just overhead I just didn't need to really have, because I had so much flux in what my mathematical pipeline was doing that I didn't get any real value out of giving formal names to all these intermediate steps. That rather say, hey, we just combine things with data shapes as long as the type coming in is an A and the type going out is C, and what happens in between is no one else's business.
So is it like a monolith and not broken up into pieces? Is that what you're saying?
My processing pipeline has 6 steps to it currently. It has had fewer or more in the past. And what I do in my current thing is, what my code does right now is, I have some JSON coming in from the client with a bunch of parameters in it, and that tells me what algorithms I need to set with which parameters for the different steps, and then it composes all those things up, and I get a closure that I simply send my video data into one frame at a time and gives me my output. And what happens all in between is just all hidden from that top layer. And
so do you never feel like you need to use that functionality, that like a closure is adequate for that?
so the closure is what I'm using to do the composition, to wrap it all together. I mean, inside the closures, I'm calling all sorts of well-known mathematical functions with names and things and stuff you recognize. But rather than saying that, hey, I've got an algorithm here, which is the main descriptor of what I'm trying to do is what my interface or my trait at the top level says I'm trying to do. That's what it is. And in fact, I'm calling this closure, that all this thing knows is, hey, it has this closure being handed to it, and you're calling the data coming in. There's no value to having a name with that. So I originally thought I had to do traits all the way through, and just realized that closures at least solved most of my problem for handling the mutable state and made it a lot easier, where I didn't have to come up with a bunch of names for things. And once I understood what send and move and FMUT and all that was, the compiler was very good at telling me when I did things wrong. It worked well.
So you feel it's easier to come back to, like, at a later date, you don't have as many functions with things, you just have like a top function like this one thing.
I just have a very complicated builder pattern, I'll call it, more than a factory, where I'm just saying, hey, this parameters comes in, and I'm going to take this, that, and put it all together, and return a closure back from my builder pattern saying, this is the thing you're going to call that will take data coming out of this shape and return data of that shape.
I think I understand, but it would be a lot easier to be sure if there was some sort of code sample. Do you know of some other common pattern that we could Google and bring up an example of this is how this works? So this right here, there's a closure that's being assigned to a variable, and then you could go pass that somewhere else, but I don't know if they have complex examples that, thank you for that, that was beautiful. I mean that sincerely. No, I mean that sincerely. That's friendship. That's friendship. That's
for you, David.
His microphone works after all.
So next time, okay, I'll make a commitment now, so I have to show up next time. I will come up with some slides that shows examples of what I did and why I did it that way.
That would be awesome.
I was planning on doing it this time, but I got sick last week, so we're out of time. But I'll do it next time.
I get it. Yeah, we all need to come up with excuses for why we don't achieve our Yeah, I've been sick the last 10 years.
You are sick. Yeah.
Indeed.
So has anyone else here used closures besides? Well, we had Levi use closures, and I forgot your name again. Was Michael used closures.
Maybe we should describe what a closure is for some people.
Bring
Not
up.
me.
Bring up.
Like anonymous function.
Is this some of the training code you have here, or
What?
where does this code come from? Is this from?
Oh, I found it on Google. There's this website. No, I didn't. Actually, that's a lie.
This is a way too complicated example of a closure. Let's go back to Google and let's do a Rust closure.
Well, that's yeah. This is they're not good results. So, did you ever a year ago or so? Had anybody done searches for using Tokyo? And everything on the top list of search results was, this isn't a complete example, but, or don't use this. And these are the top results. So a closure, are you asking what a closure is?
I know there's somebody here that messaged me and said they wanted to know.
Okay,
So
well,
I was just making sure.
What do the other options under 9.2 show for closures, like capturing versus type?
But yeah, I don't use them.
well, I can give you a basic description of what it is. So when you create a function, you can access that function from somewhere, and you can have that function be a trait. So this is what he was saying: traits versus closures. So the question is, how do you make a function useful to you? And if you're using class-ish oriented design, then the functions are attached to the objects. So the function is attached to the state. And then, like he was saying, if the state's really complex, then you have to go into nested states. So you have parent object, child object, or in the case of Rust, a lot of times you have to call functions because it has to pass mutability back and forth and keep track of scope, and so you can't even call the thing because then that would move it, and so then you have to call a function which returns a mutable reference that's going to expire, and so it can get really complex.
So,
in general, this can.
So this example is a bit too complicated here, but if we look at that line that says let print equal double bar, print line, etc. So.
If we want to make this look less complicated, we could just do. There we go.
Okay. So that double bar is actually your chance to say, this is where I'm going to declare the variables I want someone to pass to me. Okay? But you notice inside the code it's referring to this variable called color, where color was defined elsewhere. So closure does this wonderful job of being able to capture the context in which the code was written. So I don't have to define everything within the function. I can say, hey, I want to grab the value of color as it exists right now and refer to it in my code. But if you do it right, you can then take this result you've got back. You could think of it as, this is sort of like a little mini anonymous class almost that you have that says, hey, I can declare something which optionally has input parameters. Maybe it doesn't have input parameters, but when I call it, it will execute. And I didn't have to declare member variables because it just, magically captured their value from the variables I'm referring to at the time I composed and created the closure in the first place. So if you put under that double bar, if you put like X in there.
Let me see if I can put an X in here, if I can get my mouse back over here. This is actually quite awkward trying to.
Do you want to just copy it? Is that, are you in IDE right now, or maybe the Rust playground?
It's more the having displays and function and
So-
recording and camera.
So can you bring up the Rust playground?
Rust playground, yes. Yeah, and there's like mega lag between this display, the mega lag there.
But
So-
context is everything, right?
Yeah.
You're not gonna do this.
Yeah. The Rust playground, by the way, is just a wonderful
Literally,
place.
It is context. See, I have to move the mouse really slow because it's mega laggy between when yeah.
So just copy out the line that referred to color in the first place and the print function from your Rust by example code.
Oh, that's much better.
Okay. Okay. Okay, and we'll say, well, let's define a closure now. We'll release that. Let my closure, let doer, whatever you want to call it, doer of things equals, and put an X in there, and just and put two of the close brackets in there where we're going to have one of them refers to color, or green, I guess in your case, and the other one refers to X. Weird code. X comma color.
Hello, green X1.
Okay.
Wait, yeah,
It's weird, but okay, it will.
No, I mean.
Okay,
that's,
then.
Don't we need to say what X is?
Well, you.
Main.
Okay, go down more.
Sorry, gosh.
And now.
Rename either green or color at some point.
Oh, well,
Yeah.
Yeah, thank
Yes.
you.
And now call the closure on the next line down.
This whole discussion makes me think I'm not using them enough.
You're not.
And give it and put in a value of 2. Okay? See if that compiles. 50-50 chance it does.
Don't we need to tell it what the?
Oh, you need to have a semicolon at the end of your close parenthesis of the doer of things.
Oh, yes, so that it will know to capture that. That still gets me. They should have just had return. The return keyword is a beautiful, should have a snake.
Yeah, yeah.
Sorry.
That doesn't have anything to do with return, that has to do with the let. When you do a let,
Right,
you need
but
a semicolon at the end.
But we've already decided the semicolons are something to
Okay,
argue
hit
about.
run.
You know,
Well, do of things might need to be changed in line 7.
You have to have that on line 7 be the same function as line 3.
Yes.
Is there capture by is value and reference the thing in Rust? Like
There we go.
Yeah, you have to do a
Okay.
move if you want to catch the actual value.
So if I were to have returned that closure, suppose I actually in this function was having the return be the closure itself, rather than calling doer things and return doer things to some other place, saying here's the closure I made for you, sir. Then what it will do, it will capture that, and if it's by value, hey, great, that works great. It will automatically just copy the value and everything's fine. But if it's not by value, if it's something more complicated, then it will do a move on that, and you have to make sure the type you have has some way that it could be sent to another thread context.
The move is before the parameters. Yeah, if you were to try to access color after the definition of the closure, I don't know if you'd be able to do it by value. If you were to try to...
Yeah, well, maybe, because it's not...
No, I mean, if you were to try to println on, say, line 6, println color, right, and then also call doer of things afterwards, I think it will right now... Oh, no, it should be fine now.
Yeah.
If you were going to try to move it, right, then
Yeah.
it would actually be
So
owned by the
go
closure.
ahead and say print above doer thing, say print line, and put color in there. Do you have to? Will that work by itself, or you still have
No,
to put
you still
you have to
need
put
the
the
string.
parentheses? Yeah.
They made it really easy.
Gosh, the lag on this is
That was
driving me nuts.
Okay, run it.
So this should work because color is captured by reference inside of the closure, I think.
They both can refer to it because it's
Well,
basically metacopies as well.
What wouldn't work though is if we made this mutable, then this is gonna break.
Yeah, well,
Whoops. Oh, I didn't mean to hit that. So now this is gonna break, because now,
You have 2 references.
Yep.
I don't. That's a warning, not an error. I think it's actually working.
Okay, let me,
Is it because he only tries to mutate it once?
That should. No.
okay. Oh, gosh.
Bane of my existence right
Yeah, nice
now.
try. This
Should we
is
have a
Rust.
discussion just on the difference between string and stir?
Strings, that's one thing.
String versus stir? That banged my head for a while.
Yeah, that's my level right now.
Ah. Alright, we're just,
That's why I say use the number 2. You know, just integers are so much easier to deal with.
but it's grammatically, you know?
2 can be a color.
What's with the
Hexadecimal,
annoying print line syntax?
Okay.
because it's a
So
macro.
this, but the problem
You've
here,
got a mutable variable, but it's being borrowed immutably.
well, if I
Yeah.
kind of borrow mutably, then, what do they say? Oh, wait, no.
Well, that won't. Go ahead and say mute x.
Hold on, let's say color is equal to blue. Is this gonna do it for us?
Yeah, but you know, that's
No.
string.
And I think you'll still need a semicolon at the end.
Nice try.
Okay, now can we get the error we want? Yes!
There we go. Borrowed
Yes.
checker got you.
Yes! Finally!
We broke it
The error
successfully.
on this failed!
I was hoping for that.
Well, this is
That's what I wanted to do.
By the way, hello to those of you that are watching on YouTube and Twitch. Feel free to drop us a comment. It'll show up in the little chat is ready to display messages window, ostensibly.
No, he's not just.
So part of what's beautiful about this closure, or closures in general, is that because of type inference, I did not have to declare a type for x. That once I use my closure in my code with some type, it automatically inferred what x had to be, and as long as I didn't try using 2 different types in the same thing, I was fine. If I wanted to do that, then now I'm into generics, which I know some of you dislike, so we won't talk about them more at this meeting today.
No, we can talk about things that people don't like. If somebody doesn't like it, you know, they can go out and eat a slice of pizza.
Terrible.
Well, one example where working with closures, I wrote a generic to allow me to compose my closures together, where basically it allowed me to say that, hey, I have type A and type
You
B.
offended him. He left to get pizza.
No, he specifically said drink, which I think is not the signal that he's offended.
My combination closure was actually a generic that said, hey, I take something of type A, which returns a type B, and the second thing I'm putting in here is something which takes a type B and returns a type C, and I'll return something which combines those 2 together. That was a generic that takes 2 different closures and combines and returns a 3rd closure.
Gotcha.
And because it's a generic, it works, and I don't have to be worried about any function types or names or anything like that.
So are generics for us like C++ templates?
It's like the STL.
Okay.
They're similar in some ways, different in some ways.
Interesting. I've always kind of viewed it as like elaborate copy and paste.
But in my experience with C++, the STL is something which is sort of like the preprocessor on steroids, where you describe things and things will copy and pasted in. And if you made a mistake, your compiler will spit out 3 pages of stuff you can't read. In Rust, when you use generics, and you make a mistake, it may print some words at you. You have to go look up what they mean. But it is very helpful to know exactly why it doesn't like what you did. It's comprehensible and helpful.
I think C-Link's a little bit better at it, but I don't know. It's a mess when you have a template.
So in this
Yeah,
quote,
one of the things that makes templates different than generics is that although template expansion is type driven, the templated expression itself doesn't have a type, whereas generic expressions have types of their own.
yes.
Hey Jay, before you switch, I'm curious, if you switch lines 10 and 11 and remove line 5, will it fail?
Let's see.
Because right now you're mutating color after you call doer of things, and I was kind of wondering, you can usually only have one mutable reference or exclusive or multiple read-only references, right? So if you try to mutate color while doer of things hasn't been called yet,
So
and if you remove line 5,
get
so
rid
it's
of get rid of line 5,
yeah.
and I predict it won't compile.
That's what I would think. Because now you're mutating it before do of things is called, so
compile it.
So it shouldn't be able to have that reference still. But. Okay.
Yep.
Cool.
Because it's borrowed.
Interesting, it said it's never read. Whoops, why does it do that?
But I can't assign to it because it's borrowed.
Yeah, hold on.
It says never read, but it's print line in there.
Oh, right, okay. So it's borrowed here, and then I can't assign to it. Interesting.
Yeah, because it's currently borrowed by the closure. So the reference exists within the closure.
Yes.
And then when you try to assign to it, it's already borrowed, so it can't be mutated.
So what is it?
It's borrowing it immutably, is what the closure is doing.
Yeah, but even though it's borrowing it immutably, it's the whole either or of mutable and one mutable reference or multiple.
Well, this is the kind of thing where I imagine when the compiler is 10 times slower than it already is, and the language is 4 times smarter, it will let you do this because it will be able to tell this is actually safe. There is no conflict of interest here.
See, I actually think that it probably won't, because there's probably a logic bug stuck if you end up letting the compiler do that. Because right now, it's like when it's defined on line 3, you're expecting a certain value to be captured. And then if you go and kind of change it from underneath it, you may not expect that. So I almost like it better this way.
Well, so typically though, I don't disagree with the liking it this way, but typically though, in languages that have closures, the closure closes over the value for the lifetime of the value, and if you call the closure twice and the value has changed, you've written bad code, A, but B, this is acceptable.
Put an ampersand before the X,
I think
please.
because of A, you would probably just, this seems more correct.
If we want to say that we're actually doing something by reference there.
So that would have copied it by value and probably not ampersand.
Well, that won't change anything about color, right? It'll only change the semantics of beautiful.
Yeah.
Yeah, you're already capturing the color by reference, unless you put a move in front of the closure.
Yeah, we haven't defined it. Put a move in there. Get rid of the ampersand, put a move.
No, it's outside of the.
Oh, sorry.
So does Rust have like? So it sounds like it has moves. So is there L value and R value and all that stuff?
Move means I've given ownership of the memory management of that pointer to the thing I'm moving it to.
Yeah, if you were to switch 11 and 12 back with the move, it also won't compile. Because color will no longer be owned by the main function at all.
Yeah, so try compiling now.
I don't even think that we could leave the print line in here. I think that even the print line is.
Yeah, go ahead, leave one of them on comment so the compiler will show that, yeah, it won't compile. Oh, you got it right there, okay.
Yeah,
So.
on line 9. And then the error is scroll down a little bit.
Scroll down.
Well, now it's.
Yeah, there's an error.
Okay.
Yeah, you can't access the pointer anymore.
Because it's been moved into the closure.
So that's move, and the other one was reference, but can you capture it by value?
That's what move is.
So
But that's
go
not
ahead and
value,
get rid of
that's-
your
that's
comment
taking-
lit up be there,
taking ownership.
but get rid of the mute on color.
Get rid of
Yeah,
the
you-
uniform color.
You can, but it
And let your print
requires
thing be
some
back.
boilerplate.
And put which print back?
Yeah,
This
let's
is a
put your print
common
statement back
frustration,
in.
Actually, that they have a working group on.
And
in
this
the
should
Rust,
work.
like project right now.
What?
Um,
Oh, no, because it's moved.
here, I can show
Okay,
you.
so one
Yep.
because it's moved.
Yeah, so even if it's immutable, it's saying you're still not allowed to touch this thing because I moved it. And,
However,
but you see the,
if it implemented the copy trait, then you would still be able to, because it would do a copy instead of, it would do, that you get to choose what kind of by value, whether it's moving by value or whether it's copying by value.
But if you copy it and modify it inside doer of things, you won't be able to access that value because it's a copy outside of the closure.
That's right.
that's right. So yeah, this compiler's smart enough that if you defined the copy, it would have called copy to make its own copy of your data, so you could do whatever you want with it, and you could still refer to it on the outside, but the outside would be referring to a different copy than you are internally to your closure. So the context I use this in is, a lot of the time is the issue that I'm trying to return something to some other function to call to do my processing, but I have to set up, but I have to pass some processing parameters into that, which may be unique to that algorithm. But all the caller cares about is I give a certain data structure in, I expect a certain data structure out, and a closure is a very convenient way for me to say, even if it wasn't mutable state, I could say, here's all these parameters my algorithm needs to call my functions inside, put it all into a closure, and what I would also do with a closure is that if I had defined those things as mutable, internal using fmmute, which we won't get into this, I'll do it in my slides next time, I could allow that thing, much like a miniature anonymous class, have state which mutates every time I call that closure.
Alright, this is a really big table. His question is whether or not we can move by value into the closure while still owning it from the outside, right? So that it's essentially copied. And you can do that by making, I just have a little
Clone.
Did you use
yeah,
an RC?
I have a block where I define color equal to color.clone. It says it's only in that scope, that's what gets moved into the closure. And then the outside color is actually still owned by the function.
Lehigh, you could probably explain it better than I can. Explain the difference between copy versus clone.
Well, so a clone is like an explicit copy, but if you want your, if you have sort of a trivial piece of data, like an integer or something, that you typically give it the copy trait, which means that you can simply and easily, it's not expensive to make a copy of the data, and then when you pass one of those by value, it doesn't move it, it copies it instead. So that makes sort of an implicit copy, like typically happens with numbers. So it'd be really inconvenient if you had a bunch of numeric variables, and every time you used a numeric variable, every time you passed it to something, you either had to pass a reference to it or move it, because I mean, it's just a number, right? You can just copy a number trivially. So why not do that?
specifically, I think one of the semantics that's expected for copy is that the actual literal bytes can be copied verbatim using like, what's the C copy?
Memcopy.
Memcopy, right? So the expectation is that nothing else needs to be done except for an actual memory copy, where clone can have other implicit behaviors.
And so that's why strings are a problem, because it's like the deep copy versus shallow copy problem in C or C++. That if I have a structure that refers to a string, which is a pointer, I just can't copy the pointer value.
Because the struct that owns it.
Because it says, oh, I'm just pointing to the same place. No, I have an ownership problem now. I have to have that thing be a string class, or some other thing where I can copy of it, but I just can't just copy the pointer like you could with memcopy in C. Because that's bad.
In Nathan Stock's Udemy course, I think that's how he described it, is it's like a deep copy versus a shallow copy. So the deep copy is the clone, but the shallow copy is just the copy.
Do we have Mr. Cleancut online tonight?
No, he said he was busy.
Okay.
There was something in particular.
Cleancut's his name on whatever.
Yeah. Discord.
So this Rust playground, by the way, I just find is just very, very, very nice. Especially if I'm trying to play with some syntax I don't quite understand. I'm in my project. That rather than trying to create a unit test or do something there, say, okay, how does this thing work again? Let me go look at the documentation. Let me see if I can do a foobar type example of my code here. And if it works here, great, then I can put that into my code and go from there. I find it a very useful tool. Anyone else use Rust Playground?
Yeah, I use it right now.
No, so it's funny because I stick with JavaScript usually because I'm a front-end developer, and all the time I'll like find a JS fiddle for the thing, for doing exactly the thing I'm trying to do, and we're like, there it is. That's exactly how you do it, and then it's so easy after that.
In some languages you have a REPL, read, evaluate, print line thing. In functional languages, like you do that. I use that for the same thing, because you can, with a REPL, sort of define what your code is and get it right and say, okay, now I've got it and I know it works right.
Yeah.
Now I can use it in my program, and this takes the place of that.
Because how many times have you tried to do something complicated and you're like, oh my gosh, I was doing this totally wrong.
Or 98% of it is correct, but you did one.
Yes, yeah, 98%, that's what it is. 98% is correct. And then the little bit like,
So if you do use the Rust Playground, the limitations you have to live with is that, of course, you can't refer to any custom library that you have. It has to basically be the standard library that you're referring to. And it's single-threaded. So if you want to play around with threading stuff, yes, you can. Just recognize that when you run it, it's all running single-threaded.
They do include, I think, the top like 100 crates that you can.
Yeah, so very, very common things, but you can't go beyond what they've already. You can't tell it to include something else that you haven't done.
and it can't go outside of the library, like you can't talk.
Yeah, there's no network access.
There's no network access.
This is very, yes, there's no network access. This is very well sandboxed.
Yeah.
If you're thinking like people run arbitrary code, you want to do that? Which, speaking of which, you know, on Amazon, anyone here use Amazon Web Services Lambda functions, serverless
I've
function?
heard of it.
I messed with it.
Of course.
So basically the idea that if you have some event upon which you want to trigger some processing code, rather than having a server running for itself, you just give the function over to this thing that gets called when the event comes in. Think of it, they created this thing to run arbitrary code. They wrote that virtual machine sandbox wrapper thing in Rust. I forget the name of it right now, but they've done that. Firecracker, yeah. And they're advertising for more Rust programmers now because they realize how valuable it is. But that means Lambda came out several years ago. They've been using Rust a long time. They must have used that using 2015 edition probably to do that, based upon its age.
It's called Firecracker?
That's their internal name for it, yes. But the technology which allows them to run arbitrary code in their this Lambda function thing, that sandbox they wrote in Rust to guarantee that they were not going to have any security problems getting out of there.
I just noticed the author of Hyper, that package, like moved to
You know, there's I did a lookup and just, you know, Rust jobs are hard to find in a lot of places, but if you look at Microsoft, if you look at even Facebook now and Amazon, you do see that there are some hardcore teams doing basic technology stuff which are looking for Rust programmers.
Yeah, I don't think that Rust jobs are not hard to find if you're me. Meaning,
you want to do cryptocurrency?
No.
Okay.
Although there is some of that too.
Yeah.
But because if you are having a hard time finding a Rust job, you let me know, because my inbox, or a Go job, or a Java job, my inbox is full of people that are looking for this, that, or the other, because I run meetups and
So what type of companies are you running into that are looking for Rust? What do they want them to do?
Well, there's been cryptocurrency, there's been Amazon, and there's
some data science stuff happening now as well.
Yeah, most of it, I think I've posted it into the Rust Discord as it's come up. There's been 3 or 4 people that have reached out to me directly, and I'm getting the sense that there are Rust jobs available. There are more Rust jobs available than there are Rust developers to fill them. So Rust is a good thing to be learning right now.
So is there anyone here who recently had an epiphany for how they use Rust, or Rust made them think differently about their code that they could share? Someone who maybe just started Rust last month and so therefore everything's new?
Yeah. This was really good to go over this. Like, this was good.
So I had been tinkering with Rust for a while, and just like I had built this little microservice using Warp, which Warp is built by the same guy who makes Hyper. It's just slightly more usable. And so I was trying to make this microservice, and I got it working, but it wasn't like anytime I modified one thing, everything broke. And so I went through Nathan's Udemy course, and like literally just finding out about Cargo Clippy and running that on my microservice. Like, it's cleaned up a bunch of stuff, and I can modify things now, and not everything breaks. Maybe just the one function that I was working on broke, and so I think Cargo Clippy is actually kind of amazing, and I wish I had known about it sooner. But I think also just those little beginner things that he mentions, and I mean, like, some of the things I was getting caught up on was configuration, and like I was trying to test my little microservice is called Hum, and so I was trying to use Hum and like Hum or ::: API or something, and I couldn't use it in my own test. I'm like, well, what the heck? Like, I'm looking at Warp, I'm looking at these other libraries I'm using, and they're using their own package. And it was as simple as adding a source/lib.rs. And once I added the lib.rs, suddenly I could use my own code that I was writing. And so there's been a lot of just like really simple configuration things that, because I'm like reading examples on different websites rather than reading through the manual, I was missing. And so I think just learning those little simple things were big.
For other languages, there are linters or code smell tools that will point out things you think you're doing incorrectly. But I really like Clippy because it will tell you, you know, this isn't the way you should do it, that you should do it this way instead, rather than just tell you did it wrong. It says no, do it this way. And it works.
I like that they give reasons too. They help you understand. That's helped me like understand much more about the way Rust is actually thinking about what I did wrong. That's pretty cool.
That's all I got.
Now, question about closures. So if I run closures, one thing that's different about that and passing them around as opposed to traits is that if I have something which if I'm passing something around based upon the trait, I'm actually doing dynamic dispatch on that, like a vtable in C++ for those of that language, which means I'm incurring an extra level of overhead to call that function. So question for Levi. When I'm using closures, Levi, am I using dispatch in that as well? Am I adding an extra layer of dynamic dispatch performance penalty?
No, because you have the pointer right there, the function that you're calling, right? Well, I guess it's sort of, it's dispatch via function pointer because that's what a closure is. It's a combination of a function pointer and a structure containing the captured variables.
The reason why I'm asking the question is, in my old way of doing things, where I was declaring all these traits and then returning traits to things to call stuff, I realized that I actually may have, I don't know if it probably wasn't that significant, but I was introducing a performance penalty relative to closures because of all the dynamic dispatch I was introducing. Whereas I'm just calling a function pointer when I do closures. So the closures actually should be more performant.
Dispatch is also just calling a function pointer.
Do you expect any performance difference? Do you expect any performance difference between dynamic traits versus closures?
I'm not sure really. I wouldn't expect a whole lot, but it's hard to say. I mean, the way you're talking about how it's put together, there's sort of, it's kind of got dynamic dispatch of some sort baked into it because you want to be able to change the pipelines.
Yeah, it's dereferencing a lot of pointers internally somehow, I'm sure.
So if you used traits and it had trait bounds instead of trait objects, and you were able to define a pipeline in terms of, statically define the pipeline in terms of trait bounds, then that would eliminate the dynamic dispatch and could potentially open up more optimization opportunities for the compiler.
Has anyone here used Rayon in Rust?
I've used it a little bit.
So Rayon is a library which essentially allows you to take wherever you might use an iterator, like iter parentheses. If you have a collection, like a vector, you can replace iter with its equivalent in the Rayon library of just, you can get your algorithm working single-threaded. And then you just change it, if you refer to the Rayon libraries, with par underscore iter, or par underscore chunk if you're using chunk, and all runs multi-threaded. And like a lot of stuff you tend to do when you're new, when you see something great, you want to use it all over the place. So since my code all had to run very fast and I had all this stuff I wanted to do, every single place in my code where I had an iter, I was using par iter or par chunk or what have you. And then I realized, what Rayon is really doing is that the first time you call it, it's setting up a thread pool, but it's using that same thread pool all the time. If you call Rayon a million times, it's not going to create a million thread pools. It's still the same thread pool it does over and over again. But there's still some overhead that it's doing in order to, one thing that Rayon does, it does work stealing. It's saying, okay, I'm going to potentially send this off to different threads. I'm going to see who's got stuff and who doesn't have stuff. And I realized if I had a vector as my top level thing that I'm processing, even if that's a vector of very complicated classes, even if it's a vector of vectors or something, all I should have done, and it sped up when I did this, is just call par iter on the very top level and let all the rest of my code just be regular single-threaded stuff. Because in my case, since each of the items in that, since that top-level thing was a real big honking thing, all my thread pool was busy doing was carving that up into 10 pieces if I had 10 cores and processing that.
So it's enough work that it can parallelize it, but it doesn't have to do as much context.
Just do it up at the top level.
Yeah, because then you don't have to sacrifice all the context switching of switching between threads
Yeah,
and cutting up work.
Why do I have to do all this context switching down here to say if I have a big chunk of work up here,
yeah,
if I'm operating a collection in the first place, just do it at the top level and leave all the rest of your code just normal single thread stuff, and it runs faster. There is an overhead for Rayon to start up. In my case, I'm processing. I process my data. I have 50. I take the video data in 50 images at a time, every one of them has 750,000 pixels at 16-bit color, it's grayscale. So that's a big chunk of data. So dividing that up to go do stuff. Oh, and I'm doing that and analyzing that in 432 places. So yeah, I've got enough stuff there that if I'm I don't know if you think of a millisecond as a long time. If you're a Python programmer, you may think milliseconds not a long time. So in Rust code, a few milliseconds is a long period of time. And I'd say if you're doing something which takes less than 10 milliseconds, trying to spin up threads or use Round to do it is silly. But if you have something which is going to take you 100 milliseconds to do, Round does a very good job of splitting it up and going to town on all the cores you've got. So yeah, I know lots of data science stuff in Rust. I can't network program to save my life right now. I've never gotten to async await because I'm just working inside the context of foreign function interface from an external library. But I will learn one day, once I have to do a networking problem, then I will learn.
Have you written networking code in other languages?
Excuse me?
Have you written networking code in other languages?
No, because in my life, most of the time, for being the algorithm guy, I'm called by someone else. I'm the servant to some other code, which is usually not calling me. Often, that will be the wrapper around my code to deal with the networking stuff, and I've never had to do network programming because usually I'm just the one I'm being handed in process the data structure to work with.
Honestly, I think that's part of why I've ended up more on Go than on Rust, is that for a long time, with Go, you can get, they had lightweight threads, super early, and Rust had them, then sort of got rid of them, and then, I think, async is now a thing again.
Yeah, it is still kind of rough, yeah.
Whereas, Go routines have been around, perfectly stable for quite a while.
Yeah. So in my code, I'm CPU bound and memory bound. I'm not IO bound.
Yeah.
If I was IO bound, I could write a node.
Node is really, really good for some things. Really, really bad for networking. If you need to do something that isn't HTTP.
Is there
Something else you would do.
cross-platform, I know this is kind of silly, but does Rust have a pretty decent networking library?
No.
Rust's philosophy is kind of the opposite of Python's, where they don't really include a whole lot in the standard library. They're really leaning on external crates for a lot of things, which is really cool because you can get the crate you need unless you can't get the crate you need. And then it's not.
But you could do that anyway. You could always go out. They need to bless things. They need to grow a pair and bless things.
Rust does not come with batteries included. In fact, you may have to assemble your own batteries. Because we can blame it, since Lehigh is here, we can tease him and blame it all on the embedded people. So if you think, there's a lot of embedded code running there with C and C++, especially C. And if you are thinking about, the fact we were just joking before about how you're running Python in an embedded environment here, and that's just blows my mind to think of Python running an embedded environment compared to what I'm used to. We're counting, lock-up 8-bit processors and all that stuff. So if you think of someone who's saying, I'm running C code in an environment where I've got only a few K of memory and I've only got an 8-bit processor or whatever that is, I'm living in that type environment, I won't even have an operating system. So if I'm now going to run Rust in that environment to replace my embedded code, and I don't have an operating system, and I'm not allocating memory, there's the no standard, they call it no standard, no STD. I don't want to have this huge standard library that has to come with all that. And also, if I'm porting into a platform, I want to minimize my standard my stuff I have to transpile over and figure out how to make it run. And so for that reason, Rust leaves a lot of the batteries included stuff out of that. And the problem I'm having with that right now is one of the things that keeps away from the async standard thing right now is you have to choose, when you do Node, you don't have to worry about what runtime you're using. It's built into Node. If I do Rust, I have to choose what runtime library.
Well, and every library you want to use is going to have to hey, yeah, we support Tokyo, or we support we support async STD.
Yeah, so if you're doing asynchronous programming, And if you're doing turtles all the way down where you're calling code which itself is trying to be asynchronous under the hood, then you have to be consistent all the way down on which library that you're referring to.
It can get pretty painful. Yeah.
So that's why I wish that even, okay, if you're not going to be part of the standard library, at least say, and I think they've sort of done that because they now have the standard library version of async, the STD version, that's not actually in.
You mean like the future, the future trait is defined.
There's the future trait, and they're working on trying to standardize the stream trait so that some of the core functionality, as long as you're not calling runtime specific functions, you can create libraries that are agnostic to the runtime that they're running on. And there's also some shim layers that can help you to adapt things that expect one to run on the other. But
yeah, it is unfortunate.
There's definitely warts there still.
Yeah, as far as I'm aware, they don't have like any intention of bringing in a blessed runtime, though, right?
No.
Okay.
They're trying to abstract it away.
Yeah. But that's kind of painful because it ends up meaning that you need to bring in, there's like the futures util crate that you almost certainly can't escape from having to pull in. So it's like by not having things blessed, you have alternatives that essentially everybody's centralized on anyways, but aren't quite as unifying.
So the other place where C code is still dominant that people want to replace with Rust for its memory safety and so forth would be Linux and Linux kernel. But there's a reason why they're hesitant to bring Rust into the Linux kernel. And it all has to, and my understanding, Levi, is mostly to deal with how we deal with panics. Is that correct?
I'm not sure exactly. I mean, they've got tentative approval now to do it, and it's.
They've got tentative approval to do it with drivers.
Yeah. But it's not.
Well, I actually read the thread that Linus Torvalds mentioned, and it has to do with the fact that you would end up panicking on an allocation, right? A lot of the standard library expects to be able to use an allocator that is expects ways to work, right? It's not what's the word? You don't get, if you're going to try to allocate memory, you don't get a result back. You could panic instead. So if you're writing an operating system kernel, you can't panic in that code. You need to be able to roll back to something else. So you need to be able to see that an allocation would have failed, which is not something that currently happens in STD Rust. Did I say that in a way that made sense?
Yeah.
Right. If you try to allocate a vector, you're not going to get a result back on whether or not your allocation was successful. You just get that variable back. But if you're in the kernel, you need to be able to know whether or not an allocation failed.
So panic in Rust is if you find yourself in a case where you say, okay, I'm hosed, this is unrecoverable, I just want to give up and die, it's sort of the equivalent of doing exit 0 in C. But
I assume doing kernel programming in Rust, you would be in a no standard library environment, and you would define your own kernel specific foreign function wrapper API to the kernel allocators and whatnot.
Yeah.
So you wouldn't use this.
And I think,
Something that calls the normal kernel allocators.
and I think that's what's going to happen. They're not going to change the language to make it more Linux friendly. They're going to change the libraries it works with, so you're not calling any code that uses panic.
Right.
So it'd be like if you got rid of panic, which is just, it's a fail-safe thing. It says, oh, I'm doing something really bad here, like I'm accessing memory I shouldn't. I'm going to shut down the entire program so I don't corrupt and do something non-secure. Well, that would be great, but if you're flying an airplane, that might be very bad. So if you think that, one thing I also like about Rust, similar to Go, that you have this very nice system returning errors as opposed to throwing exceptions. I hate exceptions, I love results. Returning results and errors. So if you said you forbade someone from ever calling panic, instead you always had to return a result or an error, whatever you want to call it from the language you're in, then yes, it would be a lot more Linux friendly in that case. In the driver case, I understand that drivers are the first place you're going to go with Rust because Linux is supported on a whole lot of platforms. And since drivers are usually platform or device specific, If you write something that only works on a PC, Windows, or on a PC or something, that's okay because you're not going to need a driver for that in your 8-bit microprocessor environment. But I'm very excited about Rust getting into Linux, the kernel, because I've blogged a few things or pasted things LinkedIn. Both Microsoft and Google have published that 70% of the security errors they have to deal with are from memory mishandling. So 70% of all the security issues you have from zero-day attacks would go away if you had written that system programming in Rust. That's a multi-billion-dollar incentive right there. If you think of the Defense Department and why they loved Ada in the first place, Ada had some nice guarantees around it, but when you have to write code for an F-22 or an F-35 where you have to put 100 million lines of code in something, you can't find enough Ada programmers to write that much code. You have to hire an army of people. They switched to C. Did they use C++ in the F-35?
I think so.
Terrifying.
Okay, so they're using C++, C and C++ in the F-35 and F-22.
How do they stay in there?
I think there's actually a lot more verification tools in the C++.
They're
using a different kind of computer, right?
They
have a very specific. I actually watched C++ conf talk from an Air Force programmer guy or something. Talked about their code guidelines and whatnot before.
I mean, like even in Google's, if you read Google's C++ style guide, no exceptions allowed. Everything in Google code, you return an error, you do not throw an exception, because exceptions are very expensive to unwind, and they're squeezing every cent they can out of their back-end servers. So there's a large enough ecosystem of C++ that yes, you can get the tools and do the things, and you can hire programmers by the thousands and the hundreds of thousands and review each other's code 50 times and do all that stuff. It's pretty hard to go out and hire 10,000 Rust programmers right now, so we're not quite there yet. But I do see that if we make this issue about getting libraries that don't use panic and get more people trained in it, we will start seeing, we're seeing cryptocurrency right now, because how many cryptocurrency programmers does it take to do one of these sites, I don't know, but it's not thousands. That eventually I think we will start seeing Rust make itself into operating systems and and military systems, because it's more reliable, but they just can't do it now because you need to have enough programmers to write 100 million lines of code. I mean, even in a car, I just read the other day that in a modern BMW, you pay more money for the code running in the car than you did for the engine cost to manufacture.
That scares me.
That you have in a modern BMW, you have over 100 million lines of code running in that car.
I may have written some of those.
And it's not one monolithic application. It's a distributed system. You've got processors all throughout the thing talking over the CAN bus and so forth. So think about that. You've got more code in your car than you have in your Microsoft Windows operating system on your laptop, if you're using that, or OS X 10.
But Windows is totally stable, so I mean, I'm sure you can scale that up.
But some people have the Mars rover badge, right, on GitHub?
I got it.
Right?
Yeah.
Yeah. It's like I put in a comment on React or something, you know? I'm part of the React repo. I'm in Mars.
Hey, we had somebody on YouTube ask a comment a minute ago, or ask a comment.
Make a comment.
Yeah.
You speak English, Ben.
I speak the English.
Yes.
I wonder what about stack memory allocation? How do they handle that on the Linux kernel? I have no idea what I'm talking about. You actually have more code in a modern CAN than a modern airplane. I think that's supposed to be car, but I would accept CAN as well.
The 7087 has a lot of code in it. A lot of code. And that's just the entertainment system.
Oh yeah. Yeah, sure.
But the
What I wrote for BMW stuff was for one specific, a family of secondary subwoofer amplifier things that are in some of the higher end sound packages you can get.
That's cool.
Yeah. So they were talking about one in particular. I forget the I series, whatever the electric BMW series is. it was more than the development costs divided by the number of vehicles they were selling and all that. It was more than $4,000 of code in every car.
That's just insane. Can we just get back to where the AC will work consistently? Can we just get back to that?
They live in Europe. They don't need AC.
Oh, right.
Well, now with global warming, they'll feel our pain from Arizona. So.
Well, if they just turn off the blockchain, global warming ends.
I do get how this is though, because I rented a Mercedes SUV over the summer, and the little touchpad stopped working at some point. I was like, that's weird. Maybe I turned it off somehow. And then by the end of the trip, the volume control didn't work either. There was some system that was just like slowly degrading, and if you tried to change the volume, it would like, I'm gonna turn it down. You see the volume go down, then it would go back up, like a random amount. It was pretty cool.
Well, because the car is running so much code, do you think you could solve that bug by just getting back out and entering the car again?
Yes.
Yes.
Turn it off, turn it back on.
I have, now granted these are older, but I have a 2006 Prius and I have a 2006 400H, which is a RAV4 hybrid. And I have to turn it on and turn it off and turn it on again all the time.
On the highway.
I'm sure that would work great with self-driving cars. There won't be any issues. I'm sure.
Try to turn it on.
So
If written in Rust.
Yeah.
I don't have problems driving on the highway. The problem is getting the car to start because it's got a seat sensor and it's got you got to put things in the right order. So if the door's open or if you try to put it in gear, because like a manual, now manual takes on a whole new meaning. An analog car, in an analog car, you can open the door, put the key in with your foot out the window and turn it, and whatever state the car is in, it will behave according to that state. But with the electric cars, the gear shift doesn't matter because it's just a button, and the AC doesn't matter because it's a touch screen. And so to get the car in a state so that I enter the car in a state, I leave the car in a state, I enter back in a state, it's not reasonable. It's not reasonable to do that.
Someone with a Tesla, their entire display just stopped working. They had to take it in to Tesla. They're like
I was just
How do
gonna
you take it off?
Yes, that's-
specifically was driving it with no displays working, which is you don't have the speed.
And this is why I believe that there's absolutely be no problem whatsoever with their self-driving code.
Right.
Not at all.
Yeah, of course. I
That's
have
a
the same
program.
problem with
I
my
don't
Chevy
trust
Volt. I
self-driving
keep
cars.
driving down this
Yeah, I was trying to test it out and explain that to my brother. I was like,
the
where's the
whole
way?
display rebooted as I was driving.
I'm like,
Oh my gosh.
Not to to put a damper on the fun, but we have reached the 9 o'clock point.
The witching hour.
Yeah, we've reached the witching hour, and so I think it'll.
The lights went out here.
Get out.
Lights are going out.
So
Okay,
cool.
so for next time, I will prepare some slides around the closure stuff that I did, but that would not be a whole hour. And so if someone else could do the second half or the first half, I think that'd be great.
Yeah, so I forgot my piece of paper to pass around. Actually, we can use this one. This is okay.
So
I'll
will you
even share my
rewrite
real
the
code.
BMW code for next month. Have that all ready to put in, right?
Yeah, just make a PR to BMW.
Appear to BMW. They have open source. They have open source and stuff, right?
So let me just pass this around real quick. Or you can just put it in the Discord, but if you put it here, then I'll actually maybe have it for later. But just put your name in either something you want to learn or something you'd like to teach would be great.
Fun with closures.
And then some contact information, a phone number, an email address. And then I'm going to go ahead and put into the chat right now the Discord invite. So if you're not already in the Discord and you're online or something, here, I'll get that to you. Okay, invite people, yes. Unfortunately, my computer's freaking out because I have about 600 tabs open. Not quite that many, maybe 100, 200.
You have 6 tabs.
No, not that few.
What an amateur. I think I had about 800 tabs open earlier.
I have had 16 gigabytes of RAM on my home PC the past 8 years because I got tired of having 3 different people log on to the family PC into their own accounts and leave up Chrome with 60,000 tabs.
We can do this workshop again, maybe. I can at least get us up to the point of having blinky lights and, well, maybe, it depends on how much the code has changed since the last time Levi and I looked at
Do
it.
you have to wait 6 months for parts again?
No, I've got all the parts. The parts have been sitting around, so I have.
Good, because I don't think we're getting much from China in the near future.
Yeah, okay, well, there's that. But yeah, I have, I think a full set of 30 of them because I got more and then
Yeah.
Corona, so.
Even without political problems, do you know how long ships are waiting on average at the Port of Los Angeles right
I don't
now?
wanna know.
2 weeks.
I don't wanna know. But we could do the embedded workshop again. I could, like I said, I can get us up to the point of the blinky light, and you have it right here. If you just wanna buy a kit and go through it, this right here will get you up to the blinky light, and then I should probably upload. I do have recorded somewhere all the stuff that Levi did on his own, and I could just upload it unedited because the idea of editing that is not realistic at this point. But that's one that is it's pretty cool just to get the blinking light. But if we took the other stuff too, he got the rotary button working. Is he still here on the? Yeah, he's still here.
Yeah, it's still here.
So do you know? Does any of that code still work, or have you seen anything
Yeah,
on the
not too long ago, I went and got it all working again with the latest stuff. I'm not sure if I've got it pushed up yet, but I'll just have to try that again.
All right, I'll give it a go too, because I think that would be good to do next year. Maybe do it again in March. Maybe March is our embedded workshop month or something.
Okay.
All right, but let's go ahead and get cleaned up. Let's leave this space nice and squeaky clean so that we have good reason to be invited back. Thank you very much. I didn't do a shout out at the beginning because we didn't have a formal start with a presenter as usual, but thanks very much to Jeff and Vivint for giving us a pizza and location. We're extremely happy to have that. And Jeff, if there's anything you'd like us to do to plug Vivint and on the YouTube Twitch channel thing, you know, if you've got a little logo you'd like us to show at the beginning when we do an introduction or something, just give that to me.
Okay, I'll see. What we got?
Okay.
Thanks.
I'm just longer
Is
gonna
it
have
the
the
Vivint song?
data center.
We're not IBM. IBM's got a whole song book.
Oh, okay. Yeah, you should get like a little, you know, you
All right,
read a little script at the
for those of you
beginning.
that joined in on the Twitches and YouTubes and the Jitsis and all those things, thanks for those of you that contributed with the questions and comments. Like and subscribe and all that shenanigans, and feel free to join us in person. You know, it's just it's really easy to get into the United States right now for those of you that are on the other side of the globe. So don't worry about a thing. Just come right on over. All right. Anyway, yeah. Like, subscribe, hit the bell for personalized recommendations, and share with friends. Check out the channel. We've got a couple of playlists on the Utah Rust channel that have some good content in them, especially the stuff by Nathan Stocks.
I did.
And
So from our
yeah,
top page,
all that.
I think I just searched Vivint